Good morning, everyone. My name is Sharanteya. I am from CSM branch, semester 1. So, today I will be representing a tech talk on the role of object oriented matrices. In today's world, software systems are becoming larger, more complex, and more interconnected. To manage this complexity, the developers rely not only on the good designs but also on quantitative ways to measure the quality of their software. That's where object oriented matrices come into the play. They help us to evaluate how good our designs relay is more adjust by opinion, but by through measurement data. Introduction. Before we go to deep into matrices, let us assume why even we need them. Matrices is simple terms are measurements. In software engineering, matrices help us to assess quantitative like complexity, maintainability, and performance. When we talk about the object-oriented matrices, we specifically focus on systems building using object-oriented principles, classes, objects, inheritance and encapsulation and polymerism. These matrices allow us to look at designs and characteristics and ensure that our systems remain sufficient and reliable and easy to maintain as they grow in size. Without these matrices, it is very hard to know where our designs work and where our designs is weak and what parts of our system may become problematic in future. What are object-oriented matrices? So, what are actually object-oriented matrices? They are quantitative measurements that capture the quantitative aspects of object-oriented software systems. In other words, they give us as numbers that reflects how our classes, methods, and objects interact with each other. For example, a matrix can tell us how many classes depend on another in coupling. And other can tell us how cohesive a class is, meaning how well its methods are related. Others measure inheritance depth, how many methods a class has. The matrices transform object concepts like good design into concrete, measurable properties that can be analyzed and compared and improved. Need for matrices in object-oriented matrices. Why do we need matrices? Well, as projects grow, it becomes impossible to rely on only institution or code review. For instance, a class is too many methods, has too many methods, maybe it's doing too much and violating a simple responsibility principle. A high coupling value might mean the code is tightly connected and making the chances are risky. How caution could suggest a poor class is designed? By using matrix, we can improve the maintainability and relatability of software. They can also uh, compare different designs and monitor the project progress and ensure the uh, constant quality and understand the across the teams. So matrices don't just measure; they also guide better designs. Types of object-oriented matrices. Object-oriented matrices are grouped into several categories depending on what they measure. Class level matrices. They focus on single class. For example, cohesion and coupling show how independent the internally consistent a class is. Method level matrices. These look inside individual methods. For example, cyclometric and complexity measure how complex a method flow is. High values mean more difficult, code is to test and maintain. And third one is inheritance matrices. This measure how class relate through the inheritance. Uh, Matrices like depth of inheritance tree and number of children tell us how deep the broad our class hierarchies are. And fourth one is object level matrices. These analyze objects and interactions include matters like lack of cohesion and coupling between the objects and weighted methods per class. Together, these matrices give us a 360 degrees of view of software design quality. Let us understand some of the most widely used matrices in detail. First one is depth of inheritance tree. This measures how depth a class within an inheritance hierarchy. A deep inheritance tree can indicate code reuse, but it can also increase complexity because changes in base classes can ripple through the subclasses. Number of children. This counts how many subclasses inherit from the parent class. A large number of children can mean high reuse but may also increase the testing effort since a change in the parent class affects all the children. Coupling between the objects. This measures how many classes are connected or independent or a given class. The lower the CBO, the better because less coupling means fewer ripple effects when changes occurs. Lack of cohesion of methods. This indicates how methods in class relate to one another. High lack of cohesion of methods operate on different data suggesting the class it is trying to do too many things. Weighted methods per class. This measures total complexity of all methods in the class. Class with the change weight methods per class to be so too complex and harder to maintain. RFC, response of a class. This counts how many methods can be executed in response to message sent to the class. Higher RFC means class has more possible behaviors like it increases testing complexity. These methods form the core of what we use to evaluate project-oriented designs. How methods support quantitative attributes. Now let's see how methods connect with key software and quality attribute. Reusability. Methods like did and NOC show how classes are designed for reuse. Maintainability. WMC and LCOM tell us how easy it is to update the refactor code. Reliability. Coupling methods like help us to ensure the changes in one class and won't break others. Understandability. Simple inheritance and low complexity make the system easier to grasp for new developers. In short, methods help us to translate quality goal into measurable indicators. Applications in real life projects. In real life, in real world, software development object-oriented methods are very useful in many ways. Let us see some ways. Code review. Teams use metrics to identify classes that are too large and too complex. Refactoring. Matrices guide developers for what part of the code are need for simplification. Fault predictions. Study shows that class with the higher coupling and complexity are more likely to contain bugs. Automated tools. Tools like SonarQube and CheckStyle and or Visual Code matrices analyzes automatically compute their matrices and give healthier report of your project. This approach make your matrices essential in maintaining the code quality in larger scale systems. Benefits of using object-oriented matrices. Let us summarize some of the major benefits. They provide objective numerical data for evaluating code quantity. They provide design consistently and maintainability. They reduce long-term development caused by detecting issues early. They help us in making decision making, for example, deciding whether the refactor to rewrite or of a module. They promote accountability and transparency within the teams since design quality becomes measurable. Overall, Metrons turns the art of software design into more of a science. Limitations and challenges. However, it is also important to recognize the limitations. Not every matrix directly reflects software quantity. For example, a low WMC doesn't always mean a better class and context matter. Different programming languages and coding styles can affect metric values. Metrics can be misinterpreted with a proper experience. And finally, an accurate measurement of often require automated tools. So while metrics are so powerful and they should be complement to not to replace human judgment and design experience. Conclusion. To conclude, object-oriented methods are essential or part of our modern software engineering. They allow us to measure what our measure unmeasured the quantity of measure of design. By tracking metrics like coupling, cohesion, and inheritance, developers can continuously monitor the improve their systems. Used correctly, this leads to better maintainability, reliability, and performance. Ultimately, producing software that stands and text that makes the stands of test of time. So, thank you for listening.